This lesson is to find the inverses of functions and the graph of these inverses. Inverse is the switch of the values in a relation. Like if you have x and y, we know that there is a relationship between -2 and 10, -1 and 20, 0 and 30, 1 and 40, 3 and 50. When we say the inverse of these relations or functions, it's simply the switch of the values. So if you have y here as 10, 20, 30, 40, 50, the inverse of this relation is simply the x becomes the values of the y, which is now 10, 20, 30, 40, 50 for x, and y will be -2, -1, 0, 1, and 3, which are these values. Inverse relations and functions is simply the switch of the values. We are given the function y is equal to x plus 12. So we want to find the inverse function of this given function. Step 1, switch x and y. So how is that? When we switch the x and y in the function, if you have y is equal to x plus 12, the switch will be x is equal to y. It's simply switching the position of the y and the x. So now you have x is equal to y plus 12. Step 2. So because we want the function, we should solve for y. So after the switch, solve for y. How do we solve for y? These constants should go to the other side. When this goes to the other side, it becomes negative. So it will be x minus 12 is equal to y, or simply y is equal to x minus 12. The inverse of y is equal to x plus 12 is y is equal to x minus 12. Let's have another one. This time we have a number, an a before the x. So we have a y is equal to 4x plus 12. We find the inverse of this function. Step 1, switch the x and the y. So that will be the x now is the y here, and the y here is the x here. So step 1 is the switch. X is equal to 4y plus 12. Step 2 is to solve for y. So to solve for y, you need to leave 4y alone. This should go to the other side. So it becomes x minus 12, leaving 4y on the other side. To remove the 4 here, we need to divide both sides, because what you do on the left, you do on the right. So we divide both sides by 4. Dividing both sides by 4, we're getting these values. These 4 is cancelled, so y is alone. And we are left with x minus 12 divided by 4. You can actually write y is equal to x minus 12 over 4, or we can simplify this, because the 12 can be divided by 4, becomes 3, but x is just with 1 here, so it's an x over 4 or 1/4. So in writing, the function is y is equal to 1/4 x minus 3. The inverse of y is equal to 4x plus 12 is y is equal to 1/4 x minus 3. This time, let's graph inverses of functions. We are given y is equal to 2x minus 6. So let's get the inverse function of this. The first step is to switch the x and the y, then solve for y. So we have the switch here, minus 6 will go the other side, becomes plus. The 2 will divide the whole thing. So you've got the y is equal to x plus 6 divided by 2. So the 6 can be divided by 2, which is 3. X is with the 1, so it retains to be as x over 2. So the inverse function is y is equal to x over 2 plus 3. So this is the given function. This is the inverse of the given function. To graph these two, there are two ways. The first way is to give values for x and y, to find the values of y given the x, or to just use the y is equal to mx plus b, which we learned before. So let's start with the first step. So we have the x and the y. We'll just assign the value of x and then we'll get the value of y. So let's use simple whole numbers. 1, 0, 1, 2, and 3. When x is 0, 2 times 0 equals 0, minus 6, you're getting a minus 6. When 1 is for x, 2 times 1 is 2, minus 6 is minus 4. When x is 2, that becomes a 4, minus 6 minus 2. When x is 3, that's a 6, minus 6 is a 0. So you're getting a minus 6, minus 4, minus 2, and 0. Now we can easily plot this, but let's work with this inverse function. So let's assign x and y again. Now, because x is divided by 2, while you can assign any number for x, negatives, and any positive values, it's best to use numbers that can easily be divided by 2. So we're trying to avoid decimals. So I would be using the following numbers: 0, 2, 4, and 6. Because these numbers can easily be divided by 2, so I'm getting rid with decimals. So when x is 0, divided by 2 is 0, plus 3 is 3. When x is 2, divided by 2 becomes 1, plus 3 is 4. When x is 4, becomes 2, plus 3 is 5. When x is 6, divided by 2 is 3, plus 3 is 6. So we're getting these values as 3, 4, 5, and 6. So because we've got these values, we can start plotting. So let's plot the first one. When x is 0, y is negative 6. When x is 1, y is negative 4. When x is 2, y is negative 2. When x is 3, y is 0. There you go. Or simply enough, with mx plus b, we know that negative 6 is the y-intercept. So you've got the negative 6 as the y-intercept. We know that 2 is the slope. So we're going 2 up and 1 right. So we can continue plotting the points by counting 1, 2, and 1 to the right. 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 Same thing here. We've got 1, 2, and 1 there. Simply, we can connect the points and form the line that is y is equal to 2x minus 6. So let's have the line that is the inverse of 2x minus 6. When x is 0, y is 3. When x is 2, y is 4. What's that? Okay, 2, y is 4. Okay? When x is 4, y is 5. When x is 6, y is 6. There you go. Now, using the y is equal to mx plus b, we know that positive 3 here is the y-intercept. And that's the y-intercept, that is the 3. The slope is 1 over 2. It means we go 1 up and 2 to the right, or 1 down and 2 to the left. So we can continue with 1 down, 2 left, 1 down, 2 left, 1 down, 2 left. Or if you want to continue here, 1 up, 2 left. So if we'll be drawing the line, we get this line that is y is equal to x over 2 plus 3. Now, we learned before that the inverses means a switch with values. Look at this one. 0, 6, negative 6. X is 0, negative 6 for y. So the inverse of this is when x is negative 6, y is 0. When x is negative 6, y is 0. That's the inverse. Let's try this one. 1, negative 4. The inverse of this is when x is negative 4, y is 1. Let's check. When x is negative 4, y is 1. So the two graphs are correct. The two functions are correct as the inverse of the other. Let's have another example. This time we have radical functions. Y is equal to the square root of x minus 1. First step, switch x and y. So now x is equal to the square root of y minus 1. Next step is to solve for y. So how do we do that? We need to remove the radical sign first. And to do that is to square both sides. So x squared, the square root of y minus 1 is also squared, and that will give us an x squared is equal to y minus 1. Because this is now free of the radical, the negative 1 can go to the other side so that y can be left alone. So it's an x squared plus 1 is equal to y, or we rewrite that as y is equal to x squared plus 1. The inverse function of the given is this function. So you have a radical function. It's now converted to a quadratic function. Now we are ready to graph. Again, there are two ways to graph. One is to assign values, or the second one, just go straight with graphing as we learned before, starting with the origin, looking at negative 1 as minus h, looking at plus 1 here as a k. So let's assign values. Now, because this is a square root, it's good to assign values for x with a minus 1 to get an answer here that is a perfect square to avoid negatives. So I chose 1 so that 1 minus 1 becomes 0. The square root of 0 is 0. Then the next number I choose is 2 because 2 minus 1 is 1. The square root of 1 is 1. Then I choose 5 for x because 5 minus 1 becomes 4, which is a perfect square, which is 2 for the square root. 10 minus 1 is 9. 9 is perfect square, so the square root of 9 is 3. So we're getting those numbers 0, 1, 2, and 3. When we go with y is equal to x squared plus 1, there is no problem with the x values because these is squared. So any number will be squared. So you can choose any numbers here, negatives and positives. So let's do negative 2, negative 1, 0, 1, 2, and 3. When x is negative 2, becomes 4, plus 1 is 5. When x is negative 1, becomes 1, plus 1 is 2. When x is 0, square that is 0, plus 1 is 1. When x is 2, becomes 4, plus 1 is 5. When x is 3, that's 9, plus 1 is 10. So these are the numbers. Now, we learned before that the inverse functions or inverse relations have switching values. Now, look at this. We have a 2 and a 1 here. Look at the inverse. The 1 is x, y is 2. We have a 5, 2 here. So the inverse should have a 2 for x and a 5 for y, which is a 2 for x and a 5y here. See, that's the inverse. Now we're ready to graph. Let's graph the radical function. The radical function is half of a parabola that is sidewise. So 1x is 0 for y. Let's make it take. Okay. 2x is 1 for y. 5x is 2 for y. 3x, 10x is 3 for y. And we don't have a 10 here, 9, 10. So if we'll be plotting that, it will be over here. with a 3. So that's how to plot that. We just connect the points. We connect the points and we get this graph. That's the graph of y is equal to the square root of x minus 1. Now, with transformation lesson we learned before, the minus 1 is with x, so it is like an h. So it moves the parent graph 1 unit to the right. See, that's the origin. It goes 1 unit to the right. This is the original point for 1, 1. It's 1 unit to the right. The original unit for the next one, which is 4, will be here, 1 unit to the right. The next unit is 9, 9 here, which should be a 3. That's 1 unit to the right. That's what we learned before. Now let's plot this. When x is negative 2, when x is negative 2, y is 5. When x is negative 1, y is 2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 5. When x is 3, y is 10. 8, 9, it will be over here if you will try to plot it, which of course is reflected on the other side. So the idea here is we can now connect the points, and connecting the points will show us the parabola because it's a quadratic function. And the other side, oops, it may not look perfect, but we know that we have a parabola which is for y is equal to x squared plus 1, and we have half of the parabola that is sideways for y is equal to the square root of x minus 1. Now we've learned how to find the inverse functions and the graph of these inverses.